Working on a 2002 Toyota Highlander V6 gas engine. Vehicle came in with a P0 171 and a P0 174. These are the lean codes, right? Bank 1 lean and Bank 2 lean. We're idling, see 700 RPM. I'll let the video play here in a moment, but look how high our short-term fuel values and our long-term fuel trim values are. This system is really trying to correct a lean condition. Not only that, at idle, your grams per second of mass airflow should be pretty close to the engine size in liters, and it's a 3.0. We should be reading roughly 3.0 grams per second at about 700 or 800 RPM. Now watch how this fluctuates as I let it run. I'm going to play the movie now. Okay, it's kind of bouncing all over the place. Idle's changing some. The vehicle is kind of in a misfire. It's not bad, but we did a mechanical compression, I should say a relative compression test. Passed the test, no problem. Look at it, bounce up to, of course, we're now at 1600 RPM, and at 1600 RPM, you back up just a little. At 1600 RPM, this value should have doubled, the mass airflow value should have doubled of engine size. Now, granted, it kind of doubled, what we're reading before, at least, didn't it? But if we're supposed to idle at 3.0 or roughly 3 grams per second, this should be cut close to 6 grams. And now we're going to go about 700 or 800 more RPM. I'll speed that up here a little bit. And as soon as it hits about 21 or 2200 RPM, I think I'm going to stop right there. So we were at 800. Went to 1600, now we're at almost 2400 RPM. This should be closer to, say, 9 grams per second. So the mass airflow is not reading accurate. That's my whole point right now, okay? And look at the fuel correction. It's better than it was at idle. And look what the short-term fuel correction did. It virtually zeroed out. We've got a vacuum leak here, okay? We've got a vacuum leak. Look at what we had at idle, 700 RPM. We are in serious compensation, it's trying to compensate. So, but up here at, let's get it back up to about 21, 2200 RPM, 2400 RPM, where I should be reading, there we go, roughly 9 grams per second. And the fuel trims have come down remarkably on the short term, yes. Long terms have come down as well. Again, a vacuum leak, that's how it will behave. The higher the RPM, the less of fuel control compensation will have to occur, will need to occur. I really think we're looking at a vacuum leak here. Now we decided to remove the mass airflow sensor. It's the original. I think the vehicle has about 208 or 260,000 miles on it. Look how black and carboned up that little mass airflow sensing element is. I'm going to flip it over. And look at that, it's much cleaner. It should look like that on both sides. So we're going to go ahead and clean it off. We'll see if that makes a difference. I know a lot of folks like to do that, and that sometimes it works. We're going to clean it off and see if it makes a difference. Okay, we put the mass airflow sensor back in, started it back up. I'll let the movie roll here in a moment, but we didn't really make any major changes or improvements, did we? It's still bouncing around. at idle, and we still have some pretty high numbers on the short-term fuel trims and the long-term fuel trims. If we would have made some kind of valuable correction, so now we're at a higher RPM now, that's why the mass airflow changed. But my point is, once again, at the higher RPM, short-term fuel trim compensation reduced, because that's what a vacuum leak does. I guess what I want to say is that we're still not made any improvements. We've got more diagnosis to do. Now we decided to replace the mass airflow sensor based upon how our grams per second, wasn't reading properly. We haven't started the engine yet, obviously, but what should happen if this was a true fix, the moment we start, you'd see these values up here probably go -10, -20, trying to work in a direction to pull these long-term fuel trim numbers down closer to 0. Short-term, long-term learns from what short-term is doing, okay? And again, these numbers should really jump up, really go negative to help pull these towards 0. Let's see what happens. Okay, we start the engine up, and these values did not really increase. Now they're staying low. Maybe things I haven't calculated yet for this new startup cycle. Again, these zero out after each key on engine off. Now we've restarted the engine, but these are staying high. Okay, I don't think we've made a true fix yet. I think that's the point I want to make here. Let's see what happens. Do we go to a higher RPM up here? Yes, we do. But we haven't found the real problem yet. This should be more consistent. That should, at 2,000 RPM, that should be much higher than 6 grams per second. Now, we had already run the engine with the new mass airflow. By turning the key off and starting it back up, in fact, we haven't started it up yet, and look at what the long-term fuel trims did already. Okay. So I think this had a chance to, I guess, recalibrate. But not only that, we found a vacuum leak. We found our real problem. I'm going to let the tape roll here. We start the engine. The vacuum leak had a drastic improvement on everything here. I'm not sure why these didn't go negative to help drive these towards 0, but it's like everything zeroed out. We didn't clear codes. We didn't do anything of the sort. All we did is plug this large vacuum leak back on. Of course, we've already replaced the mass air. And look how consistent and steady. Get this thing to quit being blurry at idle. We're reading a good 3 grams per second. And then we're going to raise the RPM now. In fact, I'm going to speed up the process here. At 1600 RPM, we've doubled, more than, and that's what should happen. Okay, if we were reading 3.5 at idle, then at 1600, 800 RPM more, right? Now we're reading 7.4 basically. That's double or more. Okay. And let's see what happens at the higher RPM. Maybe I can pop up the video there. And we're going to get to, here we go. Now we didn't go full 800 more, but look at that. Even at 2100 RPM, 21.5, we are at 10 grams per second. This newer O2 sensor, mass airflow sensor, is reading accurate. Granted, we found the vacuum leak later, but I think the combination of course, the vacuum hose, the vacuum leak, And the new sensor is going to make this little truck run, this Highlander run a lot smoother, even get a little better fuel economy. Okay, I've got one more video clip to show you. Okay, what I want to show you here is where the vacuum hose, first of all, this is the diameter of hose that we found. That's not the PCV hose, that's the brake booster right off the intake manifold. But over here, about the same diameter of hose, it says black hose will get the lighting better. This hose right here, I know it's kind of buried and tucked out of the way. That's the hose, not this end, but tucked up and underneath. We had to find it by feel. We could barely hear it. That's what was funny. I thought we'd have more of a right there. This hose goes underneath. It's only about 2 more inches under there, and we found an empty port. We plugged it back in. That was the true fix. So again, a P0171 and a P0174, both again are lean system codes. 171 is bank 1, 174 is bank 2. The real culprit was the vacuum hose. But changing that mass airflow sensor with that kind of miles on it, again, I think air fuel calculation would be more precise, consistent, and I'm anxious to hear back from the customer to see how it drives now. I wish to make one final conclusion. When you see long-term or either short-term, approximately the same value, okay, in this case, they're nearly the same value. That means something is impacting the entire engine, okay? Something central to the engine. That could be a mass airflow sensor, since it, is the main input for airflow and air fuel calculation, right? Maybe it's a fuel pump. Fuel pumps, if they're not delivering, they're going to starve, the entire engine, not one bank, for example. Customer did say that this did not have really a trouble going up a grade. So I thought, well, maybe it's not a fuel pump. Maybe again, it's a big vacuum leak like we found that again is central to the intake manifold that impacts the whole engine, both banks, okay? If only one bank has high numbers, then you're going to go after a misfire, a spark plug, you got a compression issue with one cylinder on one bank, maybe you got a O2 sensor or exhaust leak on that bank. But when both banks are impacted, again, it's something that's going to be central to the entire engine. And I think that's where we'll end it. Thank you and good luck.